sometimes when we have systems of linear equations in two variables, our coefficients aren't integers, they're actually sometimes fractions. So for example, this linear equation, where the first equation is 2/3 x plus 1/2 y is equal to 4, and the second equation being 1/4 x minus 3/8 y is equal to negative 3/4. Now, you can try to solve this as is using the fractions, but usually fractions imply more errors because we're not used to dealing with fractions as much. So what I want to do is actually get rid of all of these fractions by multiplying both of these equations out by the lowest common denominator. So for the first equation, we want to multiply by the lowest common denominator of all these denominators. So we got 2 and 3, and the lowest common denominator of 2 and 3 is 6. So we want to multiply this whole equation by 6. And for the second equation, we want to find the lowest common denominator of, let's see, 8 and 4, right? 4 and 8. And in this case, it would be 8. So we want to multiply the second equation by 8. So let's do that. So our new equations are going to become, so 6 times 2 over 3 x plus 6 over 2y is equal to 6 times 4, which is 24. And then the second equation is going to become 6 over 4, oh sorry, 8 over 4x minus 3 times 8 over 8y is equal to minus 3 times 8 over 4. And now this looks kind of messy right now, especially the way I wrote it. Let me actually rewrite this 8 here. But it's going to simplify to something a lot nicer. So let's simplify the first equation first. So we can cancel out, divide these 2 by 3. We're going to get 1 here, and we're going to get 2 here. So 2 times 2, we get 4x plus 6/2, that's 3y, equals 24, and that's our first equation. And then our second equation is 8 over 4, that's 2x, and then here the 8's cancel out completely, so we end up just getting minus 3y. And then finally, for the constant term, we can divide by 4, and this is just going to become 1, and this is going to become 2. So minus 3 times 2 is minus 6. So now we're in a position where this looks a lot nicer, right? And in fact, if you notice in the y variable, the coefficients are opposite. So that means when we add these two equations together, we're going to cancel out the y variable, which is what we want. So let's do that. Let's add these two equations together. So we got 4x plus 3y is equal to 24. And we got 2x minus 3y is equal to negative 6. And now let's add them together. So when the x's, this is going to become 6x. The y's are going to cancel out and give us 0. And then 24 minus 6 is 18. So now, simplifying further, we get 6x is equal to 18, or dividing both sides by 6, we get that x is equal to 18 over 6, which is equal to 3. So now we have our x, and now we have to find our y, since the system of equations is in two variables. So now we plug x is equal to 3 into one of the equations. And I'm going to choose the second equation. So you can plug it into whichever one you want, obviously. It should give you the same value for y if you did things well. So plugging x equals 3 into this equation, we end up getting 2 times 3. Oops. let's redo that one. Q times 3 minus 3y is equal to negative 6. So we get 6 minus 3y is equal to negative 6. Now subtracting 6 from both sides of the equation, we get that minus 3y is equal to minus 12, which means that y is equal to minus 12 over minus 3, which is also known as 4. So now we have our solutions for x and y for the system of equations, and we want to write our answer in terms of an ordered pair. So we want to say the solution to this system is x comma y, and that's how we write things in ordered pairs. So in this case it would be 3 comma 4.